So in simple harmonic motion is something that oscillates back and forth over an equilibrium position. That's key there. And then we can look and see it at Hooke's law. Hooke's law is F equals negative kx. So that spring has that restoring force, but the displacement is in the opposite direction. So as you increase that displacement, the restoring force increases. And so that's one of the things we want to look at and kind of address. So let's take a look at the simulation for Hooke's law. And one of the things that I want you to do real quick is just kind of pay attention. Notice as you apply a force to the spring, right? You can push on the spring, we can pull on the spring. When it gets away from the equilibrium, it starts to increase from displacement. We can also see how it happens to the force itself. So if there's no force, there would be no displacement. If I push on the spring's going to want to push back. If I pull on the spring, the spring's going to want to pull back. Okay, and so that's kind of what we're doing. Now the relationship is here, if I were to show you real quick, let's put it at 100, you'll note that the force divided by the spring constant gives us the displacement. So it was stretched to ½ meter. Now it's in the opposite direction, so we would have to say negative ½ meter. So if we go back to the presentation, you'll see that that negative sign is in there because the force is going one way, the displacement's going in the other. All right? So now let's look at example 2.